So as Dallas mentioned, that Japanese woodworking is something that's challenging and it's very rewarding. It's an experience for a lifetime. It's not something that you get into as a hobby, even though a lot of people are trying to get into it as a hobby. And it is possible to do it on a certain scale, but when it comes down to as a business, this is a totally different experience here. And as my experience started out back in the 90s, when I came to a small college in Iowa, and I met somebody who was using the Japanese tools, after 3 years, we were given the opportunity to build a structure in New Hampshire, and this was the house that we did in 3 years with 3 other guys. As we are talking about joinery, in order for you to really see what joinery is, I had to scale down, obviously, all these members, because when we talk about a natural round log that you see here with a joinery on the end of it, this log is actually a 16-inch diameter log that spans 18 feet. And we had 2 of these to crisscross in order to be able to put that inside of the building. I did not get final permission from the owners to be able to show pictures from the inside of that structure, but we'll go through some of the basic joinery techniques that we used in order to be able to complete that only 1,600 square foot structure. And it took 3 guys 3 years to do it. We didn't have much experience. We learned a lot on a job site. And we always came down to the conclusion that in order for us to be able to learn, we need to reach out to the people who came before us. There was a large Japanese influence in the 60s and in the 70s. There were people in the Bay Area, in San Francisco, who were trying to figure out what Japanese joinery was all about. So they brought in Japanese craftsmen. They brought in the craftsmen who made the tools that you can see out on a display. And it goes back to the tradition of what is Japanese. And Japan has a very long history in using wood in their architectural design. Because they were in war for so long with the Chinese, they eventually stole some of the Chinese joinery techniques, and then they perfected it, like they did it with a lot of other elements in their lives. And once they started to use those techniques, there were periods in the history in Japan where they actually just shut down. They never allowed any foreign visitors to come in, and up until 1864, I think is when the Meiji period ended, they were under a 150-year lockdown. So there was no outside influence, and they needed to perfect everything the way they wanted to do it. In order for them to be able to do the shrines, in order for them to be able to do structures like this one, this is another project that I can talk about. This is the only picture I'm allowed to show you. This is one of the largest Japanese compound outside of Japan that was built by Japanese craftsmen and American craftsmen who were interested in the Japanese techniques. On the upper left corner, there is a little sign that this is the corner. The story on this is that in order for us to be able to build a structure for such an individual, we actually scaled down everything. And several sheets of 4x8 sheets of plywood was used to display all the structures that actually made it onto this compound in the course of 15 years of construction. In 1998, I was hired to work on that little corner of that particular structure. And in 2004, I actually held the full-size pieces and installed them in place. So that tells you my learning process, that if you would like to get into it, I definitely encourage you to do it. It's a very fun experience as long as you take the frustration away, because it will come. Um, so when we talk about joinery, the first, and I'm proud to present the viewing pavilion, the Azumaya at the Japanese Friendship Garden and Museum here in Balboa Park, that we just completed last year. So from 1998 until 2024-5, I was given the task to perfect the trade to the traditional Japanese methods. I was given the chance to work with Japanese carpenters. It takes a lot of bowing, it takes a lot of patience, and it takes a certain individual, because the Japanese craftsmen do not teach. You have to watch them. The closer you watch, the more interested they are in you. And so luckily, I don't know where that came from, because I'm from Hungary. I arrived in 1991 in the United States, went to college, learned English, ran into somebody who knew how to use these tools, and then he showed me how to sharpen the tools and said, no, you're on your own. I couldn't go to Japan to become an apprentice because I was 23 years old. And they said I'm 10 years too late. Because they start when you don't have an ego. At age 10, they can tell you what to do in the shop. At age 15, they might be able to push you to that corner to do the sharpening better or do the hand planing better. But at age 18 and 20, they don't want to deal with you. I was lucky enough to be involved in certain projects like the one with that little corner where they hired Japanese carpenters. We had a lot of Japanese carpenters already living in the United States. And if you paid attention and if you watched, then you could learn, because they were willing to share. It still took me 5 years before a Japanese carpenter, we were hand planing pieces, not very important pieces at all. And a Japanese carpenter passed by my piece, put his hand on it, and kept walking. And then 20 feet later, he turned around and he nodded. And that was, and I was just like, okay, tell me, give me some clue that I'm doing something good. And he just turned around and nodded. And that was the point where I said, thank you. I got accepted. On that piece, on that particular piece, it doesn't mean, and it didn't mean, that the next piece he would accept. But that piece was good enough for him, so I could go and continue with the project. This is again the little Azumaya that we completed. And this is one of the most complicated projects that we did. I would like to come back a little bit to the beginning of what it actually takes to do these structures. This is an exhibition. In Japan, there is a carpentry museum. If anybody would like to go to Japan, I strongly encourage you to go to this carpentry museum, because you will gain a tremendous amount of knowledge on what it is. These people actually came from Japan and did an exhibition in Los Angeles. It's a traveling exhibition. They were here for a month in Los Angeles, then they are going to London, and now they are actually exhibiting in Rio de Janeiro. This just gives you a little bit of an example what is actually inside of those structures. How many different joints. And if you look through some of the books there, if you look through, there is a very large book that was actually put together by Chris Hall. Chris Hall was a person who history will remember him. He unfortunately passed away 4 or 5 years ago at age 54. But that is a book that he put together. Chris Hall actually worked in Japan for 10 years. Then he came back here and he was obsessed with roof structures and Japanese architecture. That's the most comprehensive book that's available out there, and he displays joinery that you see on the pictures up here. Most of the time, when it comes down to joinery, we would like to put pieces together lengthwise. We don't have 26-foot long pieces, but we do have 14-foot long pieces. So we use different joinery. This is basically the same joint cut into the same piece, and it actually locks together. And once you put the pin in here, I should be showing it here actually. Once you put the pin in here, it will push the two pieces into each other. And then you have a very strong joint that could span whatever length you were looking for. In order to do another joint, it's called the gooseneck, a sliding gooseneck. It looks simple, but it's actually a lot more sophisticated. Once it goes together, this is all you see. And I think I was talking to somebody here that they would like to incorporate some of these joinery into a piece of furniture. None of that will show. It's very rare that you can actually see pieces coming together. But I'm going to reveal one little secret here. So in order to do this joint in a 12 by 12, 14-foot long timber, it does take certain skills to be able to put the right numbers there. There are certain details that you have to use in order to be able to use the neck thickness and the thickness here. The little detail that you will never see is that this is not a perpendicular. This is actually angled. And inside there, it's angled too. So as long as the two pieces goes together, it becomes tighter and tighter and tighter and tighter when you put it all together. So little details like that will make the difference. And little details like this one will actually get to the point where the oldest structure now in Japan is over 800 years old. And that structure has been standing. Because what happens when you put joinery together like this one, this is a simple corner joint that you will have a post standing on top of that. But when you put together a joint like this, the pieces will move, expand and contract the same amount on both pieces. So this corner here always stays closed because the two pieces will expand as long as you use the same material, as long as you use the right kind of moisture content at that point. But that's the other part that Japanese woodworking goes back to. How do you grow your own timber? So they are not only thinking about going to Home Depot, picking up a 6x6 and then taking it back home. They are thinking about that they are planting trees nowadays on the north slope on some of those mountains. And every year they go out there and they clip the saplings. So there is no nuts for the first 25, 30 feet. Because for the next 75 years, Somebody will come out and then clip the little growth, and they only let the top grow. If you have that site 125 years from now, that shrine that we built 400 years ago will need to be rebuilt from material that we planted 75 years ago. Then by the time the tree becomes 200 years old, you can actually have a beautiful post that if you take the bark off of it, there is not a single knot visible on the outside. There might be a little bit of knot on the inside once you cut it up, but in most cases they try to use these timbers for exposed purposes, either inside or outside of the structures where it's going to be visible. So that's how you achieve quality, by looking forward. And that brings me to the point where I've been very lucky to be able to work with material. Down there on a display case next to two saws, there is an end grain. I would like you to go up to that end grain and look at it. We counted 82 rings per inch. That tree was 1,500 or 2,000 years old when it was cut. No, I was told that that tree wasn't a living tree anymore, because that tree was cut back in 1920, but because the saw size was a certain length, and I don't think they could cut over 8 feet, they had to climb up on those trees 10, 15 feet higher to be able to cut across with the hand saws and fell the trees. But because it's Alaskan yellow cedar, because it's western red cedar, it's rut resistant. So the bottom 15 feet stays in the ground. It might have started to spring some outshoots, but the material didn't decay. And that's the material that they are cutting down nowadays, in order to fulfill the Japanese demand and fulfill my demand. I know we said this. Basic joint, the most basic joint is a Mortise and a Tenon joint. It's basically a joint that looks like this and the end of a stick, and then you have a small opening on the bottom. You put it together and then you secure it with the little peg. I don't want to drive that peg too far in there because I won't be able to remove it. But this stays together. And in earthquake country, like Japan is, if this moves, this will move with it. There is flexibility in the joint. And it all comes down to, I'm just going to put this together. This is a great example of, that's basically a sliding dovetail right there, as you can see. And we have a sliding dovetail end on the other end of it. When you put it all together, this is probably going to look a lot better if I show it up. This is the look. Oh, to this one. There you go. So this would be the look that you would be getting, having a large, beautiful, natural log spanning the roof and resting on top of the purlin. So as I said, the most used joint is the Mortise Tenon. And as I was driving down here, it wasn't the first time when I always thought about it. I'm always doing the same thing. It's Mortise Tenon joint. Because this is the most useful joint in some of our structures. Now, when it comes down to the pavilion that I showed you earlier, then there are angled pieces for the roof structure that will come down to these are the hip rafters coming into two other members and the post from underneath. In order for us to be able to actually do these joints, we had to go back to the drawing board, and we did a quarter of a building on a full scale on the shop floor, all laid out. The interesting part about that is, and I can go back to here, is when you look at the rafters, it's only the center rafter is the one that's perpendicular to the beam. Everything else is turning, and the distance between the rafters is increasing, and the angle changes too. So none of those pieces are square except the center one. Everything else it's a parallelogram. Another basic joint that we use quite often is the sliding dovetail. And I don't think I have an exact piece except a mistake that I can show you. I built benches for the past month for the garden, and as a woodworker and as a good one, I make mistakes. This piece is just an inch shorter than what it needed to be. But it showcases the joint and how it looks like. So what you see, no, you don't see that. I know some people would like that, because for me to be able to acknowledge that, yes, I'm a human too. And yes, I have great tools, I have good skills, and once in a while that tape measure just doesn't want to measure the distance. Oh, I'm so glad to hear that. So, yeah, we don't see what's on the picture there, but this is basically a very simple joint. It's a sliding dovetail joint that has a housing that goes into a housing and holds two pieces together at the right angle. Very simple to make, and a very simple way to make a mistake on it too. And I wanted to talk about the tools. Obviously, we use a lot of hand tools. Sometimes we go out to job sites. I have work that I have completed in Grand Rapids, Michigan, in Chicago, in Rockford, Illinois. I cannot take all the tools with me that I use in the shop. But being a woodworker, being a business, we do rely on tools. And because we do the Japanese carpentry, we do rely on Japanese tools. And so that the tool that you see on the left side now is actually what helps me to cut the female part of this. I do need to use hand tools too, but if you look at the bottom of that piece there, I guess I can walk here. So over here you have two, it's a router. It's a router and an X and a Y. And I have two bits in there. I have a flat bottom bit and I have a dovetail bit. And the Japanese made that machine, so once you do the housing, when you drop the dovetail bit, it's always gonna go to the center. It never makes a mistake. And that allows me to cut this one on a table saw, and boom, we are done. If I was on a job site, it would probably take me 5 times more time to be able to complete this joint. And the female part of it probably 10 times. We still do need to use and clean out the corners, but as I see it here too, you have woodworking tools. Learn how to use them, buy a couple of hand tools, and learn how to use those too. The other machine on the right side is a chisel mortiser. Again, it's a Japanese model. You can purchase it here, but it allows me to do this mortise here in the center in 4 strokes. And it's a square chisel with the drill bit in the center of it. You do need to sharpen it once in a while, but at the same time, it cuts the cost down. I don't need to go there and spend a day on each mortise and tenon. I can do it in less than half an hour. And we have bits that are 1/4 of an inch wide, and we have bits that are 1 3/16 wide. So that helps to speed up the process when it comes down to a project like this one. This is actually the base of the Japanese Friendship Garden and Museum viewing bridge. It's 18 feet across and 18 feet wide. In order for us to be able to do all that joint, if you were doing it by hand, sorry, that's not going to happen. But using the machinery allowed us to speed up the process. And this is a great example when it comes down to sites, this is Rockford, Illinois. It's called the South Gate. The gate was rocking. It needed a full restoration project on it. So we ended up basically taking it off of the foundation, rebuild the foundation, and then try to piece pieces into the post bottoms, because that's where, unfortunately, they rot out the most. Incorporate joinery in them, and then put the structure all back together. That's when the hand tools are really handy. When you are on site, there is no power because the next generator is so far or the next outlet is so far. You can't get to it. You still need to hand plane the piece. You still need to make it fit certain sizes. And you need to make sure that the shape that we are trying to do so-called historical restoration. So we are trying to reuse the material that was already there and only change what we really need to change at the bottom of the posts. That brings up another interesting part here. As you can see, most of the traditional Japanese structures are standing on rocks, on natural rocks. And the posts, they look like they grew out of it. There is a certain technique where you actually put the piece on it and then you start scribing it, making sure that it's still plumb every single time you put it back down. And then eventually you get to the point when you carved out the top of the rock. So when you place it on it, it looks like it grew out of the rock. Obviously, there is a lot more to it because we do have a concrete foundation under it. We do have a threaded rod coming all the way through the rock, all the way into the post, where we cut a little hole on it and then we use a nut and a washer to tie it down to the foundation. And that's just to American standards. Back in some of those old structures in Japan, they only used, they didn't even use concrete foundation. Concrete wasn't available back then. So they used crushed stones, they used sand at the beginning, making sure that the water would come off of it. And then they placed the structures on top of it with no metal fasteners at all. The truth about the metal fasteners are that they are sometimes helpful. And there is no Japanese structure since we developed fasteners, even in Japan, that they don't use fasteners. Everybody uses fasteners. I encourage you to come down to the garden, I would say probably from May to June. We are trying to do a program. I'm trying to encourage the garden. There is a Japanese bell tower that's coming to the Japanese Garden and Museum, and Japanese craftsmen will put it together. But I'm trying to encourage the garden so they open up certain areas so people can come in and then see what they do there. So in May and June, we might be able to post something through the website here. Another example of what we needed to do in order for us to be able to do a zigzag bridge at the garden is pick 10 stones or 12 boulders, bring them up to my shop, and I have to make the joint in the bottom to match each rock. No single rocks are the same. I got to the point where I can do 2 in a day. 2 in a day? No, I can do 1 in 2 days. Sounds a bit different. This is a small example of a sliding dovetail coming together, and this is what made up the base of the zigzag bridge. Luckily, we were able to source some very nice material. And then obviously, once we are on site, even though we measure, we triple check, we quadruple check many times, we do make mistakes. Sometimes the tape measure just doesn't want to show me the right measurement. So in order for us to be able to do that bridge, we incorporated at least 4 or 5 different kind of joints. Most of these joints are definitely Mortise and Tenon that are pegged, that will, another interesting part about the peg job is that the distance from the bottom to the bottom, from the shoulder to the bottom of the peg hole is offset. So when you drive this peg in there, it will actually force the top piece to come down. Little nuances like that will make a huge difference. And then I really need to talk about what does it take to do a project like this one. This is a 49-foot long arched bridge that nobody had any idea of what the radius was. We went back years, they couldn't find anything. We eventually calculated it out using mathematics. But when it came down to making all those mid-posts that are between the mid-rail, the bottom rail, and the top rail, we ended up using 115 mid-rails and 45 top rails. Now, each of those little posts will have a tenon at the bottom and a tenon at the top. Not all of them got pegged, so they were a little small. But each of those top parts needed to be cut 8 times, and the bottom times needed to be cut 8 times. So it's 16 cuts on each of those posts, and we had over 120 of those posts to do. So you really need to be focused on what you're doing. And then eventually my apprentice, we're still not at that, you didn't, yeah. So when we go on site, we did try to, the center post and there were 5 main posts on that bridge. Where is that picture? There are 5 posts. There are 9 5/8 diameter. Those were all actually hand planed too. With one of those hand planes that it's a specialty hand plane there. So when we got on site, we still had to scribe and fit each end of those top rail and mid rail to fit the post. And because the angle has changed in so many cases, that was all just by hand. No. No. We made sure we didn't cut those short. So as going back to Azumaya and what it takes to do the joinery, in order for us to be able to do the joinery, we had to do this full size layout on the floor in the shop to be able to come up with the right angles and the right joinery for that structure. The layout goes on with a 0.3 millimeter ink pen. It's not traditional. Back then they didn't have it. The traditional one is out there, and it would be a bamboo stick, and you would have to sharpen the end of the bamboo to be able to get the flow of the ink right. But obviously we are evolving a little bit, and it's a lot easier to use different coloring for different joinery. And then this is what the finished look like. On the piece on the left, you don't see a little dummy piece. On the right, what piece says E1 is actually just a tiny, tiny piece. It was 10 inches long, and that fits into that dovetail with the cutout so that the hip rafter can come into it. This was really the first time I had the full privilege of laying all of that out. But that structure, we worked on that structure for 8 months before we actually put it together as Lego. And it only took 3 weeks to put it together. That part. The whole structure took 3 months. But in order to do the roof structure, it took us 3 weeks to complete it. I would like to emphasize that in order for you to be able to do that, you do need to go out there and then buy some tools. These tools are not inexpensive. You can get some inexpensive ones, but you can get some very expensive ones too. I'm showcasing a couple of them here. I have a set that's a full set that I use all the time, and you can tell which I use the most because that has the shortest handle on it. Or if you go to some of the mortising, the larger chisels, I mean, I had lost probably 1.25 inches, 1.5 inches on one of my handles because that's how much we are pounding on it. And for the carvers, for the people who like to carve, there are sets available, full sets with different shapes, as you can see, for different purposes. And obviously this is a fresh maker out of Japan. His name is Tasai. Some of you might know about that. But his chisels are just a work of art. Should I show it to you? Yeah. So the very interesting part and why these tools are different than the Western style is because they are laminated. My understanding is that the early tools in America were still laminated at one point. And the Japanese kept it, they perfected it. If you can zoom into this very front end, then you can see that the hard steel and a soft steel is totally different. You got it?
Now it doesn't want to focus.
Okay, well, let's see what this does. Anyway, if you play with that in the light a little bit, you might see it, but you are welcome to come back to it. The top layer looks, they call it a Damascus steel. It's basically folded several hundred times, and you can actually see the folding lines in it. And at the very end, they use an acid to take the softer parts away, and that makes a beautiful design pattern on top. It doesn't really show up on this. Most of the tool makers were actually sword makers back in the old days, but then the shoguns and the samurais dissolved. Nobody was really interested in samurai swords anymore. They started to make tools for the Japanese woodworkers. Yes, I will show you I don't know if this is. Oh, they don't see the. Do you see the video? I have a very short 12-minute video. Can you show that to them? Oh, it's there. So this was one of the hand planing contests I pushed myself through. For 3 weeks, I was hand planing continuously. This is one of the top rails, so we knew it needed to be really, really, really nice. And for that reason, I pulled out one of the nicer hand planes that I have, and that allowed me to make a piece that will be water resistant for some time. We did end up using a finish on the structure because over the course of the past 10, 15 years, I came to a conclusion that you have to use a finish if the structure is not under a roof. What's very interesting about that is that if you can see, it looks like a mirror finish, and that's just off of the hand plane. So it actually reflects back color on the piece. But it doesn't mean that this was the thinnest shaving. So making a thin shaving is a great way to develop your sharpening skills, but the surface doesn't have anything to do with that. Sometimes the surface you have to be a 2/1000 of an inch or 3/1000 of an inch thick shaving in order to be able to come up with the best surface, and I am aiming for the best surface. And I think that concludes most of it that we wanted to talk about. I would like to open it up to question and answers.
Do our Q&A. We'd like to have you stand up, wait until you get a mic, and then ask the question. We're going to have mics on both sides. So please
And
stand
in
up.
the meantime, I put out some of the resources for tools that I suggest, some of the resources for the books. So please take a picture of it. I do have the books down there, and I can probably tell you if you need it, the resources for the tools too, if you don't have a chance.
Okay, 2 questions.
Sure.
What kind of finish do you use, and can you come to my house and do some work outside?
In an hour? The wood that we use, the finish that we use is a German product called Livos, Livos. I can get it in from Canada. I can't buy it in California because of certain laws, but they can ship it in from Canada. They even developed a finish, it's a natural oil finish for horizontal and vertical surfaces, and it's different. And you have many options to put tint in it. We've been experimenting with that because, as I said, most of the structures that don't have a roof in Southern California will get so much damage by the UV.
Question, David, Scott. The larger structures, like when we build things in America, there's plenty of guidance on this is your span capability, what size beams you need. That must be a lot different using Japanese joinery. Is there much guidance, or is it all traditional?
There is a little bit of guidance to it. If we need to go and have it engineered here, it's usually the pieces are extraordinarily big, because the American engineers do not really understand that where we are actually using a post at every 6 to 9 feet in order to support that piece. So to answer your question, a lot of it is just guesswork, which will pass and which will not pass. And the first question is, if somebody comes to me, and I will have to ask you about that too, is it going to be inspected? Because if it is not, then I have the freedom to choose. And in my experience, I can tell you exactly what a piece needs in order for you to be able to span a certain distance. So sizing material comes to the point where in Japan, if somebody asks you to do a tea house, the first question is how many tatami mats would fit into that tea house? And they will say 4.5 or 8.5. So you go to Home Depot in Japan and you tell them that you have a 4.5 tatami mat tea house to be built, and they will direct you to the ceiling board that correlates to that size. They will direct you to the beam department that correlates to that size. So it's a lot of it is experience, but a lot of it is just based on certain measurements. And that's what makes a joint like this one to lay out very easily, because the square that we use, and I don't know if so many people saw that, the square that we use is 15 millimeter square. It's flexible, but every joint is designed on that 50 millimeters. So, well, except this one, because this one is based on the cutter head that's in there, that's 48 millimeter. So you have to know that. But in order for me to be able to know that the depth of the housing is 15 millimeter, it's just one line with the square and the pencil. In order for me to be able to figure this distance out, it's 30 millimeter. It's twice as big. So it makes the layout a lot easier.
One more question. Anybody else?
My name's Kirsten. My question is, what type of stones do you use